Hey guys, welcome back to another edition. Mr. Anderson here, your fearless host, leading you through the perils of geometry. Anyway, we're in section 7.3 today. Similar triangles. All right, so let's take a look at what we're going to do today. We're going to identify similar triangles using the angle-angle similarity postulate and the side-side-side and side-angle-side similarity theorems. Those should sound kind of familiar. We talked about those again when we were talking about congruence. And then we're going to use similar triangles to solve problems. Okay. All right. First of all, angle-angle similarity. Now at least this part, we didn't really have this before in congruence because this would not by itself prove that two things are congruent. And I think I even told you before that if you had angle-angle-angle similarity, that was not enough to tell you that two things are congruent. But if we're talking about similarity, remember similarity just means the same shape. It doesn't necessarily mean it's the same size. And so in this case, all we really need is two angles. And if you look at it, let's take a look at this. This probably will make some sense to you today. If you look at triangle ABC, you notice angle A is 1 mark, angle B is 2, and the other one, angle F, is 1, angle G is 2. Well, if you remember, there are 180 degrees in every triangle. So if A and F are congruent and B and G are congruent, well then C and H, what's left, has to be the same, right? So really, we don't even need all three angles to be the same. We don't need to know that they're the same. All we need to know is that two angles are the same, and then we know they're similar. If you remember when we were talking about similarity, one of the things was all three angles are the same. But we don't need to prove that. All we have to do is prove 2, because once we prove 2, we got the third one. And so, again, remember in a similarity statement, like right here, the order matters. So it says ABC, it goes ABC, and then FGH. So that means that A and F have to match up, and they do. And then B and G have to match up, and they do. And then by default, C and H have to match up because that's what's left. Okay, let's take a look at a few examples with that. All right, so we have to determine if these triangles are similar. And then if so, let's write a similarity statement. Well, first thing is, let's look at our angles that we've got here. Well, you notice here's 42 and 42. That's a good sign. We have one set of angles that are the same, but the other ones are, oops, they're not the same. But we've got some missing angles. Let's see what's missing over here. So on this one here, remember, if all triangles are always going to add up to be 180. So if I just take 180 and I subtract the 58 and I subtract the 42, so again, if I'm just going to do 180 minus 58 minus 42, I am going to get 80 degrees. So that means this is 80 degrees in here. And now, if you're looking at the other triangle here, you'll notice, hey, look at 80, 80, those two are the same. So now we have two angles that are the same, 42 and 80. So we probably don't even need to bother subtracting these from 180 because we know C is 58. This one has to be 58. And so then in this case, we're going to write our similarity statement. So again, we have to put it in the same order. So in this case, I'm going to say A, B, C. Okay, so I'm going to start with A, B, C is similar to, remember the little squiggly line, that means similar. So if I did A, B, C, I'm going to have to go E, D, F on the second one. E, D, F. Okay. So that's why we found the missing one that's 80, and we've got two angles that match up. And so by angle-angle similarity, these would be similar triangles. All right, how about this one? Now we want to see if these are similar. Okay, this gives us some new problems here. Well, think back to some things that we've learned before. the first thing that you might notice here is you've got two lines that cross. That forms, remember, two vertical angles. And so we know that vertical angles are congruent. So I don't know what the degree is on this, but I know that those two are same. I know that QXP and MXN, those two are the same. Okay, well, they're the same. Well, what else? I also have some parallel lines. And so again, if you think back to things that we learned before, remember if we have two parallel lines and a line that cuts across it, it makes what we call alternate interior angles. And we know that alternate interior angles are congruent as well. And so in this case, we've got, if we say look at angle M here, angle M, I'll mark that with 2. What's alternate interior to that? It's P. So M and P are alternate interior because they're inside the two parallel lines. They're interior, but they're alternate means they're on the opposite side of this line that cuts across there. And likewise, that N, I'll mark it with 3, is alternate interior to Q. And so in this case, again, we found that all 3 match up, but all we really needed to do was find 2 for angle. And so in this case, let's write our similarity statement here. I'm going to say here, since I marked these as 1, 2, 3, I'm going to go in the same order. So X, PQ, I'm going to call this one X, PQ is similar to triangle XMN. Okay, and that's my similarity statement. And again, I used vertical angles and then alternate interior angles to prove that. Okay, good. All right, couple other things here, other ways that we can prove similarity are with side-side-side similarity. Now, if you remember before, when we were talking about congruent triangles, we use side-side-side, meaning that all 3 sides were the same. Well, you know, when we talk about side-side-side similarity, that means the sides are, the ratios are all proportional. Okay, so again, that shows us here in the slide. It says JK, the red line, over MP. That ratio of JK to MP has to be the same as LK to QP and has to be the same as LJ to MQ or QM. Okay, so they all have to be proportional. Okay, so all the ratios have to match up. That would give me side-side-side similarity. Side angle side would be, again, that the two of the sides, just like in side-side-side, 2 of the sides are proportional. So the ratio of the red and the blue, so in this case RS over XY, has to be the same ratio as ST to YZ. So if those 2 are the same ratio, and we can prove that, and we know that the angle in between, or the included angle, that just means the angle that's in between those 2 lines, those 2 sides, then these 2 will be similar. Okay, they'll be similar as well. So S has to equal Y as far as angles, and then the ratio of SR over YX would have to be the same as ST over YZ. Okay, all right, let's look at a few examples with that. Some of these might get a little bit trickier, but let's see what we can do here. All right. So we want to figure out if these are similar or not. So here's our 2 triangles, one here and one here. Well, you know, again, we're looking at side-side-side and side angle side. So we know the one thing I think that's probably the easiest thing to figure out here is that 9 and 6 are two sides that have to go together. It might be hard to tell which way these triangles fit together, but you remember our vertical angles here. If I mark these as being vertical angles, if those are the same, then that means that the way these match up, that the sides across from that have to be the sides that'll match up. So let's look at that ratio there, the 9 and the 6. We have a ratio, let's see, this would be what, AB over DE would have to be 9 to 6. Or we can divide them both by 3, and we get what? 3 to 2. Okay, ratio of 3 to 2. Well, now here's where it gets a little trickier. You go, well, what are the other sides that match up here? Well, we want to see if they'll match up and make a 3 to 2 ratio. And so, you know, you could either match this 6 from AC with the CD side, or you could match maybe the AC with the CE side. So you could have a couple of choices there that you have to check or look out for. And if you notice here, just real quickly, we'll look at this. If it was matched up where side AC matched up with CE, that would be 6 to 5. Would that be 3 to 2? No, that's pretty easy to tell. That's not going to work. So let's look at the other one. Let's look at the side of AC to CD. And if we look at that, that's going to be what? 6 to 4, which we can divide by 2 on both of those. And that's going to give me 3 over 2. Oh, look at that. That matches. That's good. That's a good sign. So what that means is if these two have the same ratio, then we're in good shape, right? So again, notice I put AB was the big triangle on top, AC was the big triangle on top. So on this third ratio here, we want to put BC on top and then CE on the bottom. All right, so BC is 7.5 and CE is 5. Oh boy, look at that. That doesn't look so great. What in the heck's going on there? Okay, the problem here is what? We got a decimal. How do I reduce this to get it to see if it matches these or not? This is going to be really hard. Okay, here's a little trick. Well, what you can do is, remember how here we divided by 3 or divided by 2? You can do the same thing, divide by the same thing here, or even multiply by the same thing, as long as you do the same on the top and the bottom. And so I just want to pick something that I can multiply by to get rid of this decimal. Well, in this case, this is kind of a simple one because since it's 7.5, I can multiply by 2. Here, I'm going to do it this way so it doesn't look like another decimal there. I'm going to multiply by 2. If I do that on the top and the bottom, what do I get? 15 over 10. No more decimal. Okay, well, now that I got rid of the decimal, now I can just kind of reduce this fraction. And if you notice, these will both divide by 5 now. And so this is going to be, oh, look at that, it's 3 to 2, ratio of 3 over 2. Okay, so that's awesome. So what this means is we did the proportion of all 3 sides, and they all came out to be the same ratio of 3 to 2. And so we can say, yes, these are similar triangles. Let's write the similarity statement here. We're going to say triangle. Let's see. Now this might be a little, I got to make sure I do this correctly here. So I'm going to go, if I go ABC, let's do ABC. So if I do ABC, then that means I have to go on the other side, DEC. So if I go ABC, then I have to go DEC, because AB matches up with DE, and then BC matched up with CE, and then AC matched up with CD. So that's why, so I have to go in that order. Does that kind of make sense? All right, so there's my similarity statement. And then this would be the reason why we could say that is because it was side, side. That's the way we did this. Now you could have also called this side angle side, because if you found the ratio of 6 to 4 and the ratio of 7.5 to 5, you could have found that those two had the same ratio, and we knew that these two angles were the same. So that would have been a side, an angle, and a side, an angle, and a side. So we could have also used side, angle, side there. But I wanted to use side, side in this one, because in this next one, it's going to look a little different. Okay, so again, now in this case, we've got the top triangle, the small triangle, and then this big one. Okay, so that's the two triangles we're looking at. Well, in this case, but here's maybe part of the problem why we can't do side, side this time. That's why we're going to try to do side, angle, side, is side RS doesn't have a number. Side NP doesn't have a number, so I'm not going to be able to do a ratio of those two sides. I don't have that third side to look at. But what do I have? If I look at this little triangle, I've got angle M, because angle M in MNP is the same angle as in MRS. It's the same angle M. So we've got the same angle of both of those, the way this is drawn. All we have to do is look at these two sides here and see if the sides are proportional. All right, so we're going to look, first of all, in the small triangle, we're going to look for the side of MN. That's this side. We want to see if it's going to be proportional to the whole thing, which is MR. Okay, so that's going to be MN is 10. MR is what? 10 plus 15 is 25. We can divide these both by 5. So this is going to be a ratio of 2 to 5. Now, if the other ratio of the other side is the same, we're good. All right, so we're going to look for then MP, the ratio of MP, again, the small side to the whole thing, MS, which is going to be what, 12 on top over 12 and 18 is 30. Well, we can divide by 6 this time, and this is going to give us 2 over 5, or a ratio of 2 to 5. It's the same. So the ratio of the two sides were the same, and the angle in the middle was the same as well. And so in this case, we used side angle side. And let's write the similarity statement here. So triangle MNP, I'm going to start with. What? Okay, let's go back. Hopefully it's still there. My stuff sometimes kind of just takes off on me. Like that again. Okay. I am going to get this written down. All right, so MNP, there we go. So MNP, then since the side MN matched up with the side MR, that means we're going to do MR and then S. Okay, so MNP is similar to MRS. All right, now we're going to solve a few problems using similar triangles. So in this situation here, pretty much everything that's explained up here is drawn out here. It says RS is parallel to UT. You notice we've got the two little arrows. RS is 4. That's written up here. RQ is x plus 3 right here. QT is 2x plus 10 here, and UT is 10. So we want to find RQ and QT is what we're trying to find. So what we have to do is find S. Well, these make similar triangles, so we have to figure out how they relate to each other. So again, notice these lines are crossing. So we know these two angles are vertical angles. They're the same. Then we know since these are parallel, remember alternate interior angles? So that means angle R and angle T will be the same. And then angle S, 1, 2, 3, and U, 1, 2, 3, will be the same. So now that we know, now we kind of know which ones that have to match up, right? And so first of all, what we want to do is we know that the side RS, that's between the 2 mark and the 3 mark, on this one between 2 and 3 is 10. So that ratio is the ratio that we're looking for, 4 to 10 or 10 to 4, depending on how you do that. I'm going to say 4 to 10. So this will simplify down to 2 to 5, right? So this is a ratio of 2 to 5. RS, this is RS to UT. Okay, note that we did the small one on top. All right, so what I have to do then is I have to match up another ratio here that I can make a proportion out of this. So if you notice here, x plus 3 is between the 1 mark and the 2 mark. Well, what's between the 1 and the 2 here? Between 1 and 2 is the 2x plus 10. So those two have to be proportional as well. And so what I can do here is I can say x plus 3 over 2x plus 10 has to equal the ratio that we figured out over here, right? This 2 over 5. Okay, so the ratio 4 to 10 or 2 to 5 has to be the same as x plus 3 to 2x plus 10. It's a proportion. Now we solve it. So parentheses around both of these, cross multiply. So we're going to say 2 times 2x plus 10 has to equal this cross product 5 times x plus 3. Distribute the 2, 4x plus 20. Distribute the 5, 5x plus 15. I'm going to go minus 4x and then minus 15. And so we have x is 5. Yay! But that's not what we're trying to find out. We're trying to find out RQ and QT. So now we just plug it in. RQ is x plus 3, so this will just be 5 plus 3, which is 8. And then QT is going to be what? 2 times 5 plus 10, so that would be 10 plus 10 is 20. So RQ is 8 and QT is 20. Okay? All right. Fun, fun, fun. Word problem. All right, Josh wanted to measure the height of the Sears Tower in Chicago, which, by the way, that is now called the Willis Tower. They changed the name of it. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of Sears Tower shadow. It was 242 feet. What's the height of the Sears Tower? Okay, well, that's kind of confusing. So it's always a good idea to try to draw a diagram. Okay, unfortunately, there is a diagram for us already. I'm going to put it up here so we can see. So let me explain here how this came about. All right, so this here is the light pole. Okay, here's your 12-foot light pole, so it's 12 feet high, and it made a shadow of 2 feet. So this is the shadow length, 2 feet. It's like this angle here, that's like, basically this is coming from the sun up here. Okay, so here's the sun shining its rays down. So this is like the angle of the sun making the shadow here. So it makes this little triangle. Well, at the same time, the Sears Tower, here's the Sears Tower here, it is X feet tall. We don't know what it is, but it makes a shadow of 242 feet. So basically, this makes another similar triangle. The couple things that we can assume here, we can assume that this angle of the sun is going to be the same on the light pole as it is on Sears Tower, so that means this angle is the same. And we can assume that the light pole is 90 degrees as well as the Sears Tower, so we know that these are both going to be 90-degree angles here. And we know this angle has to be the same. I'll make that 2. So that means we've got, what, 2 angles that are the same. So these are similar triangles. So let's set this up. I'm going to give myself some room to work in the second slide here. So we're just going to set up a proportion. And so I'm going to do, it doesn't matter which way you do this, but I'm going to do shadow over whatever the object is, the light or the Sears Tower. All right, so the shadow of the light pole is 2. The light pole is 12. Okay, that's that one. Now the Sears Tower, since we did the shadow on top, that means the shadow is what? Of the light, or of the Sears Tower is 242, and the actual object, the Sears Tower, is X. Okay, so there's our proportion. You could simplify this 2 over 12 if you wanted to first, or just go ahead and multiply it. We'll just go ahead and multiply it in this case. So that means you have 2x equals 12 times 242. And so 12 times 242 would be 2904. And then divide by 2. And so in this case, 1452. So x is 1452, and that's the height of the Sears Tower, so it's 1452 feet. That's the height of the Sears Tower, apparently. Okay, so all you're going to do in these kind of situations is you're just going to draw the diagram to help you see it, and just compare the two similar triangles, make the proportion and cross multiply. All right, so lastly, nothing to work out, but just a little overview here. These were the different triangle similarities that we talked about today. Angle, angle, as long as you have two angles that are the same, then you know that these are similar. Or if it's side, 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 you know that all three sides are proportional. The ratios are the same on all three sides. Or side angle side would mean two sides have the same ratio, and the angle in between those two sides is equal. Okay, so that's just kind of a wrap up. I appreciate you being here for similar triangles today, Mr. Anderson. Saying see you later. Bye.